One application of stack is to use it to evaluate expressions. So now we look at such an example problem called the basic calculator 2. So we are given a string which represents the expression. So the string consists of integers and operators, including plus, minus, multiplication, and division. And we need to evaluate this expression and then return its value. So there are some additional conditions. So first, there may be spaces, white space separating them. And we're guaranteed we are given a valid expression. And all the integers are non-negative integers in this range. And the answer is guaranteed to fit in 32-bit integer. And also division should truncate towards 0. So just the standard Java or C division behavior, integer division behavior. I guess actually there's one more thing that should be specified that's not explicitly specified, which is all the intermediate results are also can be represented using an integer. So that's true. You don't get overflow in the middle. But yeah, it's the question didn't clearly specify that. It's kind of a minor bug in the problem specification. So for example, if we get 3 plus 2 times 2, the output should be 7. And we get 3 divided by 2, the output should be 1. And if we get this 3 plus 5 and then white space division, white space 2, we should do the 5 divided by 2 first. We get 2, 2 plus 3, that's 5. So that's what we need to do. So if you haven't done this kind of expression evaluation before, then I seriously suggest you to try yourself. Really spend some time trying to do it before move on to go on with the rest of the video. So this particular problem is a lot easier than a more general expression processing because we don't have parentheses. So we can't really get a very complicated expression, if you will. So in some sense, all we get is a bunch of things that are using multiple division that can be evaluated, and then they are either added or subtracted together. And because of that, the implementation of this is relatively straightforward. So what do we do? If we see a plus or minus, we can't compute yet. If we scan the through expression from left to right, when we see a plus or minus, we cannot compute yet because there may be a multiplication and division later. So for example, here when we do 3 plus, when we see this plus, we can't really do much. So we have to wait. And on the other hand, when we see a multiplication or division, we know we can immediately do the calculation because there's nothing to stop us in some sense. And because there's no parentheses, and also multiplication and division are left associative. So if we have 2 times 2 times 3, we can do the 2 times 2 first. If we have 2 divided by 2 divided by 2, the semantic is we do the first division first. And then we're always doing left associative. So because of that, when we see a multiplication or division, we can pop whatever number we have stored and then do the calculation, and then we can put the number back onto stack. So we can use this stack of integer to keep track of the result. And because we don't have a parenthesis, so at the very end, we are going to get a bunch of numbers that should be added or subtracted together. And that's actually also kind of complicated, but another insight will make it even easier. That is, because there's no parentheses, each of the multiplication, each of the negative sign, the subtraction sign, can be treated as a negative sign to the term of things multiplied together. So for example, let's say here we have 3 minus 2 times 2. Then we can really treat this as 3 plus minus 2, negative 2 times 2. So it doesn't matter how many number we have after that. These by treating this minus sign here as a plus of negative number, the behavior is exactly what we expect. We can do that because there's no parenthesis. If we have minus parenthesis 2 plus 3, then the minus will apply both to the 2 term and the 3 term. But here we don't have parentheses, so the minus term immediately apply to this number multiplied together, so we can just turn that into negative number. So with all that, that's pretty much what we need to write the code. In the end, we're going to have a bunch of numbers, some negative, some positive on the stack. We just need to add them together. So this is my Java code on 2 slides. The first slide that have the function that parse 1 integer. So the string, so this class variable strings store the current string, and the index ind point to the place I'm looking at. So and when I know the next one should be an integer, I will call this a next int. So the first, so here I will skip all the white spaces. So while it's white space, I will just keep increasing the indices. And after skipping all the white space, the next thing I expect is going to be a digit, so 0 to 9. And while it is a digit, I will be going in this loop trying to parse this number. So each time what I do is I multiply x by 10 because I see another digit. Then that means the number I parse is the only prefix of a number should be multiplied by 10. And then I add the value of that digit computed here. So when I get out of this loop, that means the number has ended. The next one will be either white space or maybe plus minus multiplication or division. So here I will skip all the trailing white space so that the next thing will be an operator. So this next int will be called whenever I know the next up I'm expecting an integer. So this is the main part of the code which calculate the value. So first is initialize the string value and set the indices to 0. And then it create a stack. At the beginning of the expression, I'm going to expect the integer. So that's the only way if a valid expression begins is to start with a number. So I read that number and then I push it onto stack. And then I will be keep going forward. And so remember this next in the function will consume all the white space. So the next one should be an operator. So I read in the operator, if it's plus or plus, I just read in another number and then push it onto stack. So they will be added at the end. If it's a minus, then I will read in the next number and then push to the stack the next negation of that number. If it's multiplication, then I know I can compute now, so I pop an integer from the stack and then multiply the next one coming up. Similarly, I do the same thing for division. And when I'm done, then when I get out of this loop, that means I have processed everything in the string. So then what I should do is the stack may contain multiple numbers that should be added together. So that's the rest of the logic. So pop the first number and then keep adding everything on the stack. So I think a few observations on this slide make the code relatively straightforward. Yeah, without this, the code can get complicated. If you need to keep track of both operator and number, it gets more complicated. So that's it for this problem.